Alright, this is Unit 5, Video 5. It is our last video for this unit, and we're going to be discussing double angles for both sine and cosine. So have that Unit 5, Video 5 note sheet ready to go, and we'll get started. Okay, at the top of your note sheet, again, we're going to go ahead and write, and actually, why don't you turn it over and write down a couple things on the back for us. And the first thing you're going to write down is we're going to start with one of the three ways that we can write the double angle formula for cosine. And there are three different ways to do this. That's why I think I have the back of the worksheets better. So the first one we're going to start with is the cosine of twice a, so 2 times a. So if a was 30, it'd be 2 times 30. If a was theta, it'd be 2 times theta. And this equals, I'm just going to tell you what it is, and then we're going to go through and find different ways of writing this. Is the cosine squared of a minus sine squared of a. So if we use one of our Pythagorean identities to write this another way, I know that cosine squared of a, this is in my mind, is equal to 1 minus sine squared of the angle. So I'm going to replace that cosine with 1 minus sine squared of the angle minus sine squared of the angle. So this was my replacement, which then simplifies to 1 minus 2 sine squared of theta. So here's one way we can write it. Here's another way that we can write cosine of 2 theta. Well, I'm going to do a similar replacement, and I'm going to say, well, sine squared of a is actually equal to 1 minus cosine squared of a. So this time I'm going to replace the sine squared of a with 1 minus cosine squared. So that's going to look like this. Cosine squared of a minus 1 minus cosine squared of a. Notice I'm using parentheses. Those are extremely important because that's going to give me the correct distribution. So when I distribute that negative sign, I end up with cosine squared of a minus 1 plus cosine squared of a. If you don't use the parentheses, you end up canceling your cosine squareds. So the third way of writing this is going to be cosine squared of 2 times cosine squared of a minus 1. And that's just collecting these together. So to write our cosine of 2a, we actually have 3 different ways of doing it. And those are the 3 ways that are written in those boxes there. Alright, so on to our sine of 2a, which actually only has one way of writing it. And the sine of 2 times an angle is equal to 2 times sine of the angle cosine of the angle. That's it. It's simple it is. Nothing squared. It's just that. Alright, if you want to copy down any of that onto both the front and the back, that's fine. But it is important that you can see these replacements because we're going to do some verifying with these double angles as well. Alright, so for our first example on your worksheet, we are going to use the identities to find all 6 trigonometric functions for each of the following. So I have this one, and the one on the next slide is number 2. So I'm going to start with what it says was where theta terminates, and terminates means where it ends, and that is in quadrant 1. So I'm going to draw a picture, and I know that my triangle is going to be located in quadrant 1. I'm going to use one of my manipulated double angles for cosine for this problem. So I know that 2 times cosine of 2 times an angle is equal to 3/5. And I know that I'm going to set that equal to 1 minus 2 sine squared of the angle. So if I continue this problem and I were to just subtract 1 to the other side, so that would be minus 1 over here, and I would have negative 2/5 equals negative 2 sine squared of theta. And I wanted to get sine squared of theta by itself, that I would go ahead and divide by negative 2. When I divide by negative 2, it's like multiplying by a negative 1/2. Leaving me here with a positive 1/5 equals sine squared of theta. Because sine squared of theta is an operation, I'm going to go ahead and reverse the operation by using a square root. So I'm going to take the square root of both sides. That leaves me here with just sine of theta equals both positive and negative 1 over root 5, or root 5 over 5. Because it's both positive and negative, I can consider where it's located on my unit circle. And in the first quadrant, everything's positive. So that makes my sine value root 5 over 5, and I can place those on my triangle. In order to find all 6 trig functions, I'm going to use the Pythagorean theorem to find my other side of my triangle, my adjacent side of this angle. And that means I'm going to use the Pythagorean theorem. So it leaves me with the square root of 5 squared plus the missing side squared equals 25, which is my 5 squared. Squaring a square root leaves me with just 5 plus x squared equals 25, or x squared equals 20. When I take the square root, I do get both positive and negative, but I'm in the first quadrant, so everything's positive. And then I end up with 2 root 5. And that's my simplified square root. So 2 root 5. So I've actually labeled my triangle for the single angle rather than a double angle. And the next thing I need to do is to go ahead and write out all 6 trig functions. Well, sine was the first one I found here. So it is root 5 over 5. Then I can find my cosine, my tangent, and I'll be able to find all 6 reciprocal functions. So the cosecant, the secant, and my cotangent. So in order to do that, I'm going to use my triangle and locate all the information. So to find the cosine of theta, I have 2 root 5 over 5. My tangent is going to be root 5 over 2 root 5, and when I simplify it, my root 5's canceling, leaving me with just a 1/2. Okay, so to find my reciprocal functions, I can do one of 2 things. I can take the reciprocals of what I have, or use the reciprocal definitions that we learned in video 1, and that is that I should take the radius over the x. So it won't matter which way I do it here, but if you want to just take the reciprocal of that, you will have to simplify it just the same. And this will simplify to just root 5. Secant of theta, well, that's the reciprocal of this one. Again, I can do 5 over 2 root 5 and rationalize it, or I can take 2, so it would be, let me erase that. 5 over 2 root 5, and I still have to rationalize this, leaving me with 5 root 5 over 10, and that simplifies to the root 5 over 2. And the last is my cotangent, and my cotangent might be the easiest, to just take the reciprocal of tangent because it's 2. So now I've found all 6 trig functions. Let's try that again. So this time I'm given the cosine of 2x equals 3/4, and it terminates in quadrant 3. Now what I notice about quadrant 3 is that both my x and y values are going to be negative because of where it's located on the coordinate plane. So I'm going to start once again by saying 3/4 is equal to 1 minus 2 sine squared of theta, because this is one of the formulas we have for a double angle of cosine. When I subtract 1, I get negative 1/4 equals negative 2 sine squared of theta. If I divide this by negative 2, I end up getting a positive 1/2 equals sine squared of theta. When I take the square root of both sides, I get both positive and negative square root of 1/2 equals the sine of theta. Well, I know that that is the square root of 2 over 2 when I rationalize it. And because I'm in the third quadrant, I want the negative side. So that makes, I can do this one of 2 ways. I can look at it that I have a negative root 2 here and a positive 2 here. That's fine. Or you could have used that this is actually 1 over radical 2 and that my negative. In that my adjacent, or my opposite is negative 1 and my hypotenuse is radical 2. Alright, let's find the missing side. So if I'm using this picture here To find the missing side, I'm going to use the Pythagorean theorem. That's negative radical 2 squared plus x squared equals 2 squared. That's 2 plus x squared equals 4, or x squared equals 2, making this also negative radical 2. This is a 45-degree triangle. I chose negative because it's going towards the negative x direction. Last thing I have to do is find all 6 trig functions. Well, the sine was the first one I found, and it was negative root 2 over 2. The cosine of theta is going to be negative root 2 over 2 because this is a 45-degree triangle. Then I have the tangent of theta equal to positive 1 because the cosine over the sine, or if you use opposite over adjacent, is negative root 2 over negative root 2. My reciprocal functions is just taking the reciprocal of this, which will end up being negative root 2. My secant of theta is negative root 2 also, and my tangent of, or cotangent of theta is equal to positive 1. Alright, next up, find the exact value of each of the following in 3 ways. Evaluate it directly, use a sum or difference identity, and use a double angle identity. Well, of course, evaluating it directly will probably be the easiest because the sine of 2 times 45 is really the sine of 90 degrees. So this will tell me that the sine of 90 degrees is 1. Okay, so that's the first part, evaluating it directly. The next thing I'm going to do is use the sum or difference. And for this one, I'm going to use the sum. So that means I'm going to write the sine of 45 plus 45. This is demonstrating that I'm adding 45 plus 45 to get 90. It's the same as saying the sine of 90, but this way I can demonstrate using the sum formula. And that will be the sine of angle A times the cosine of angle B plus the sine of angle B times the cosine of angle A. They look the same because they are the same. Excuse me. And that's a double, that shows my sum formula. Now the sine of 45 is root 2 over 2, and the cosine of 45 is root 2 over 2, plus the sine of 45 is root 2 over 2, and the cosine of root 45 is root 2 over 2. So when I multiply all that together, I end up with 2 over 4 plus 2 over 4, or 1. Perfect. The second thing I need to do, or the last thing I need to do here, is a double angle identity. So my double angle identity is going to be using the formulas that I wrote on the very first slide. You have them on the back of your worksheet. That would be the sine of 2 times A to equal 2 times the sine of A and the cosine of A. So plugging this in, I have A to be 45 degrees. So that's 2 times the sine of 45 times the cosine of 45. And we both know, or we all know, that the sine of 45 is root 2 over 2 and the cosine of 45 is root 2 over 2. So to simplify this, I multiply my radicals together, and that gives me 2 times 2 over 4, which is equivalent to 2 times a half, or 1. Alright, let's try it again with number 4. So to evaluate this directly, it'd be like saying the cosine of 120 degrees. And my cosine of 120 degrees, it's in the second quadrant, which makes it negative, is equal to negative 1/2. If I want to use a difference formula, because I used a sum formula in the last one, of course I can write this as the cosine of 60 plus 60, but I want to model it for you using the cosine of 180 minus 60, which is also 120. So the cosine of 180 minus 60 degrees is going to give us the cosine of 180 times the cosine of 60 plus the sine of 180 times the sine of 60. Okay, now I'm going to fill in all my blanks, and I know that my cosine ordered pair is negative 1, or my 180 ordered pair is negative 1 comma 0. So that makes my cosine negative 1 and my sine of 180 0. So my cosine of 60 degrees of just 60 degrees in the first quadrant is 1/2, and my sine of 60 degrees is root 3 over 2. But because it's being multiplied by 0, it doesn't really matter, and my answer comes out to be negative 1/2. Alright, finally we're going to use the double angle, and you can choose whichever formula you'd like. So if you want to use the 1 minus, the 2 times the sine, or 2 times the cosine squared minus 1, you can use any of those that you prefer. Or you can just use the basic one, which was the cosine of 2a is equal to cosine squared of a minus the sine squared of a. Either one of those is acceptable. I'm going to use this one because we haven't used it in the video. So if my value of a is 60 degrees coming from the original problem, then I have the cosine squared of 60 degrees minus the sine squared of 60 degrees. But when you're so I can basically fill in my value and square it. So what is the cosine of 60 degrees? My cosine of 60 degrees is 1/2, and my sine of 60 degrees is the square root of 3 over 2. When I square this, I get 1/4, and when I square this one, I end up getting minus 3/4 because I square the numerator and the denominator, which gives us 2/4 or negative 1/2. And I have the same answer shown 3 different ways using direct evaluation, a sum and difference formulas here, and also my double angle identities.